Hi, welcome to this lesson on calculus derivative laws. So before we have a look at the first law, which is the power law, if we had to keep using the definition of a derivative from first principles, so essentially f prime x is the limit as h approaches 0 of the average gradient formula. So as we've seen, we've did a few examples of these. Algebraically, these are quite long and lengthy complications to do, right? But if we had some sort of nice generalization or law for certain classes of functions, for derivatives, then we can just keep applying those laws without having to keep doing the first principle technique. So there's a common meme amongst mathematicians, right, that we're generally lazy. We don't like to do so many calculations, although to the contrary, you see all these media portraying, so many lengthy calculations. It's partially true. But, instead of deriving from first principles here, we have some simple formulae, which are the laws for derivatives, that just make the calculations a bit simpler. And that's all we want. Nice, simple, beautiful looking mathematics. All right, so let's have a look at the first law, the power law, or the power rule, whichever one you want to call it. So it says if f of x equals a times x to the power n. So this is an nth degree, right? This is an nth degree polynomial where a and n are real numbers. Okay, so it doesn't even have to be just a polynomial, it can actually be surds as well, because if n is a half, for example, x to the power half, that's a surd. So this even applies to surds as well, not just polynomials, so that's amazing. Okay, basically where x is the base and n is your exponent is any real number, then the derivative of f with respect to x is given by the following formula. We keep that constant a as it is, and we take the exponent n and we bring it down to the front. So we are going to multiply the entire thing by n, so a times n. And then the x, the base there, remains the same, and the exponent gets subtracted by 1. And we saw that in the previous example when we had f of x equals x cubed, for example. Yeah, your a is just 1, and your n is 3. Well, if we use the power law now, it says bring that 3 down to the front and multiply it. So 1 times 3 times x to the power 3 minus 1. So that's going to be 3x squared. And that's exactly what we got when we did the first principles rule. But look how much quicker that was. Okay, so essentially we bring the exponent n down by multiplying it by that constant a, and then subtract 1 from the original exponent n in that power term. So as an example, if f of x equals 3x squared, then the first derivative, we bring the 2 down by multiplying it, and then subtract 1 from the exponent. So we get 3 times 2 is 6, and 2 minus 1 in the exponent is just 1. So 6x. So notice we went from a quadratic, and then the derivative is a degree less. It went to a linear term. All right, so that is the power rule for derivatives. We'll have a look at the next two laws or rules, and then do some examples on them. All right, I'll see you in the next one.